in the chat. So basically, again, just today we're gonna look at a few examples. So study unit 10 and 11, and then I also have one or two of study unit, I think 8 and 9. So I was thinking, let's just do a few of those, and then for 1610, we will have a session tomorrow and Tuesday. So for those two, what I'm basically going to go through is a mock exam. So we're going to go through mock exam. So it's not online. It is. I took some screenshots and things like that. So we will be able to go through one of those, and just over the 2 sessions we will work through the exam so that you guys are prepared. And then for 1510, we'll just repeat this whole process next Sunday, Monday, and Tuesday again, so that you guys are also ready to go with your exam next. Is it in a week and a half time nearly? Okay, so let's look at study unit 10 and 11. And what I thought was interesting in some of these questions is, again, this is how the exam will also be, is some questions seems and is very easy. So sometimes one wonders, okay, but did I actually do it right? Because it can't be this easy. And then others are more difficult. So it's nearly what I've seen in most of the exams, and that is where I think you guys sometimes also make mistakes, is because you think, no, but this can't be it. So a question on degrees of freedom is really an easy one that one must get right. So the differences that comes into play is, do we do a degrees of freedom for a T, or do we do a degrees of freedom for a chi-square? And that again is the important one. So in this one, they tell us, so again, you will get enough information so that you know what to do. So in this one, they tell us we work with a chi-square, and we need to get the degrees of freedom for a chi-square. So degrees of freedom for chi-square, and is always rows minus 1 times columns minus 1. Okay, and what I quickly just want to get to that one thing from your study guide that I also thought is always nice for this chapter nearly, and I'm just gonna put it in here as well, quickly going to copy it in. So what I thought is, and you guys can just also, this is nearly one of those that if you know all of these things and know how to do these things on chi-square, you will be able to answer any question. Okay, so in this one we needed to do degrees of freedom. So let's check how many rows. 1, 2. Remember that total is not included. So we want to know how many variables there are. It's 2 minus 1. And how many in your columns. Again, 2, we're not including total. So 2 minus 1. So that will be 1 times 1, which will give us 1. If you did include total, then you would have had 3 minus 1, so it would have been 2 times 2, and unfortunately, there would have been an answer for you as well. So just be very careful when you need to look at the degrees of freedom. Don't include total. So sometimes they give you the table even without the total, but I again would think, because they want to catch you out, they will probably include the total as well. So just be careful about that, because in essence this should be easy marks. But again, if you add total, there is an answer, and then again you think you made it correct. You got your 3 or 4 points, but unfortunately, you didn't. So degrees of freedom should be easy points for you. But again, just check what they include and not include in your table. Okay, so the next one, I thought also, because also on the chat, when the study unit was running, there was questions around how do we calculate certain things, and how do we get to use the table. So what I thought was good to look at is, let's look at the numbers for you to get to the table, and then I'll show the table and how you then get to the critical value that you need to work out. So what we always look at is the significance level, so and also the degrees of freedom. Let's just look at that one. Okay, so I didn't add it in here because we are just gonna work off from a table. So what is important? So let's quickly, we know what the degrees of freedom was, but we're gonna work that out again, and then we quickly need to decide on what the level of significance is going to be. Okay, so let's quickly look at degrees of freedom. So degrees of freedom was remember, the 2 minus 1, the 2 minus 1 and 2 minus 1, which have given us the 1. So already when we go to the table, our degrees of freedom was 1. Okay, so degrees of freedom 1, so we're working within this table. Okay, so we're working then in that first line that we're going to work with. Also look at what they show us here. So they show us alpha is this area. So they tell us alpha is 1, so 1%. So remember, 1% is 0.01. Okay, so let's quickly go back to, so alpha 0.01. 0.01. So where we have the 1 degrees and the 0.01, we get the 6.635. 6.635. Okay, so again, this should be a more easier one to get. What again, one sometimes make the mistake is to look at how you would have done with t. So the t would have been alpha divided by 2. Okay, but with chi-square, it is only alpha. So that's the big difference between the two that we need to work out. And I think that sometimes was also when you guys did the assignment where some of you automatically wanted to say divided by 2. But with chi-square, remember it's always alpha that we're looking at. And again, you can, when you look at the table, they show it to you as well. I think let's quickly go to the T table as well, so that we just, I think it was chapter 6, way back. Yeah, okay, so that is not even easy to read. Okay, so I'll get for one that's in the textbook, because that nobody can read. So I'll get you the one in the textbook about what is next to the T on that table, because that is in the study guide that I have. There's no ways I can I can read that at all. Okay, so we've done the critical value that you can read off of a table. Again, when you guys are gonna get this in the exam, what will be, you will only nearly get the degrees of freedom of 1. There might be one if there's a third one here that it is 2 times 1, but the most will probably be one where it's 3 variables and 3, so it goes up until 4. But you, again, won't get degrees of freedom of 20, because so just be nearly on the lookout for how to use those first few, and normally it is between the 0.1 and 0.005. So that is normally the areas that we are going to be looking at. Okay, so for this one, again, straightforward, but if you read that wrong, you do your degrees of freedom wrong, then you will get others. So let's just quickly see the 11. Where was that? So that again is if you rate if you've done your degrees of freedom wrong, you would have gotten the others. So degrees of freedom would have given you those ones if you got that wrong. The other one was if you said 0.1 instead of 0.001, you would have gotten it wrong as well. Okay, so if you said 0.1, that would have been your option. So again, just be careful, and always when you get the 1%, divide it by 1 divided by 100 to get your decimal. And what I know it's easy to just say, okay, 1% is this or 10% is this, but it really does not take that much longer just to do it on a calculator and say 1 divided by 100 or what is 1% in decimals. Because again, very easy to just make that slight mistake and then there's an option. So nearly you can see they have made sure if you do certain things wrong, that there are options for you. So just be careful. And I know it is sometimes in the exam, again, it is you look normally at the answers first. That's what I always did. And then you see, it was 1%, 1%, 127. Yes, that's the answer. And then unfortunately it will be wrong. Okay, so relative easy ones. Remember there is on each study unit there is 2 questions. So it might be that the next one is a bit more difficult. Okay, so let's look at this one. Sorry. Okay, so here they said now we need to work out the value of a chi-square. So this now is one of those that I would have said use Excel. So yes, I am gonna do that. But we're also quickly gonna just check the method that you would have used if you guys are now not being able to do that. So that's the test statistic that we need to follow. So we will need to say my observed minus expected. So observed is for 38 minus the expected of 29.68. That's square and then divided by the expected again. So 29.68. And this we now need to do for all 4. So again, you will not get in the exam where you needed to do it for 6, because again, they will not do that. So the most likely, if you get it, will be for 4 cells that you need to work it out. So I'm quickly gonna add this to Excel as well. Okay, so we have, I'm just going to quickly put it in here. So 38, 18, 15, and 29. Let's just make it bigger. Okay, then we could have, and again, if you do get this in the exam, they must give you the expected as well, so that you don't need to work it out. So they will not give you this regional table, expect you to work out the expected values and still work out the chi-square. This again, normally it's part of assignments and not part of your exams, where they ask you to work out the chi-square test. Most likely in the exam, they will ask you to work out some of the expected values, give you a list of expected values, and say which one is correct or incorrect. But just for in case. Okay, so so you could have added in Excel already the numbers that they give you, because it was in the tables, or you can work it out. So it is the sum of the one times the sum of the other one divided by the total. Okay, and you would see that that was 29.68. Okay, so again, one can decide how you want to do it. And yeah, you can make the values that it doesn't move and all those kind of things. But okay, so this is now the observed and expected. So now again, I'm just going to do all 4 year and then sum it. You could also so I'm doing it 1, 2, 3, 4, and we're going to sum it. But there's also a function that does it, so we're gonna do that function as well. Just that we see that everything works out. So again, unfortunately now for a 1510, so there's nothing for me different in what you're gonna do here and versus what you're doing on a calculator. So yes, so please, if for the 1610, use these pre-calculated formulas. The 1510 unfortunately can't, but we're still gonna test via the 1610 if I are able to do it. So so when the 1610 guys do the mock exams and the exams, I will ask later on feedback from you on certain things. But yeah, you also with Excel use what you can, what's the most. So if there is built-in functions, use it, because again it is there. Okay, I did now something wrong. I forgot about the square roots. So again, that just quickly shows me how easy one can make a mistake, even if you are doing it in Excel. So again, when you do it on another way, that's why this normally isn't a question in the exam, because it really does take time. So it's more, I think what they will ask is that you know how to work out the expected. Okay, so there we had 11.278. Okay, 11.28. So let's just, there is supposed to be a chi-square. I just need to make sure there's so many options that we do the right one. Okay, so see, this one is chi-square distribution, so this does not take into account what we want, because here it says give me the x degrees of freedom, so this is probably going to give you the probability one. Let's see what else is there. There's a chi-square test. So actual range, it asks it for that, expected, and then see now that is actually the other way around. So that now is the p-value that we've done here. So again, Excel is not, if you look at, you need to know exactly what things you need to nearly look for. See, so now look at the time that I've spent looking at some of these, just because, so if you had it beforehand, when it is fine. Where is now the one? So if anybody else knows the one that actually does it.
From your spreadsheet, I just have cheat test or chi-test.
Okay, that's quite interesting. So it shows then that it also might have even be. So if there's also differences in the different Excel versions, then you get different. See, so it does it again. So let me quickly. So this for me is very interesting that we now have this issue. Okay, so let's quickly, just see, so there's now really saying if you were in the exam, you don't want to spend so much time on any of your questions, because this was supposed to make it simpler and not longer. So I will just check on my table why I couldn't now get to it, because it should not take this long. And it might just be, see, so that was the expected, so why did it not do that? Okay, so now we've lost lots of time if it was not pre-coded, and so again, I would have done this, because then I know exactly, I'm just following the formula. So I just followed the formula to get to it, instead of now guessing. Let's just see if that was an option, because then, okay, luckily not. So that you don't spend too much time, but before I send it, I will get you the right one as well, but it is on the original, it is in there. So again, if you're using Excel, just make 100% sure you have practiced the things beforehand, and don't now wait until the day that you write to understand all the formulas and things like that. Because then you are going to waste a lot of time to get to the right things, like this one. So I nearly now wanted to go through all the options of Kai, to get to the same answer. So just be, again, if you use it, make sure that you do it, and practice with it beforehand. In the exam, again, so what would have been just as simple to make the four calculations. But again, what I think they will ask you in the exam is, they will tell you, and I'll get one for the practice on Monday and Tuesday, because how I would have grouped a question like this together is I would have asked you for A and B, I would have asked you, or just one of them, the independence question. I then would have asked you the degrees of freedom. I would have asked you the critical value that you get from a table. I would have asked one of it to be the expected value of home and secure, or something like that. And then I would probably have given you something else. And it might even be to say what's your observed value. And that basically tests all of this, if you can do it. So that is what, and I've seen that in other papers as well. So I will just get you one of those as well that we go through on Monday or Tuesday, because that covers all the things that you should be able to do. To ask this one in the exam is probably not going to happen because it does take a lot of time. So when you guys get something like this in the exam, what I then would do is, so again, let's talk about a method to, because for 1610, this will be way at the end of your paper. So if you know you only got 10 minutes, you look at this and you're like, oh, flip, I need to now do this. It's going to take lots of time. Look at what your critical value was. So look at what your critical value was, because 99% of the time your chi-square is going to be bigger. Because how this is set up with what you're testing, independence and not independence. It's not like the chapter 6 and 7 where we look at normal distribution. So very seldom we will have the H1 as the acceptance. So most of the time it will be something that's independent. So most of the time your chi-square that you will calculate will be bigger than your critical value. So here my critical value was 6.6. So that is exactly that one. So we could have already eliminated that. I would have also been able to eliminate the other two, and then it is, at least if you've got 5 minutes left, you've got 2 options. Instead of looking at 5 options. So also when you get to some of these questions, there's certain things that as options are definitely wrong. So again, if you need to nearly make it an easier one to guess your answer, try to eliminate a few. Okay, so but again, I think what you guys will get is more of a setup. Okay, so let's get now into one of the other difficult ones. And I was now looking before I started this session to get these formulas, and it wasn't in the study guide, so I quickly just want to get it from one of the other documents I have, so that we can quickly work it out. So again, for both 1510 and 1610, we are supposed, you won't get tables in the exam. So please just be you won't get it in the exam. And also the formula pages you will not get. So just make sure that you have all of those things with you at any stage as you write the exam. So let me just, where was one of the previous exam papers where it was? Also, I must just check in our summary doc. So let me just quickly go to our presentations on that. I'm sure I had it in there so that we can just quickly. Okay, so let's quickly check. So they give us okay, let's just put that into here. See, so again, for you guys now to print all of these things is stupid. Instead of having it on a screen. So we know that we need to use B1. We need to get to the slope. They actually tell us B1, which is actually cool. So we need to use this formula. So we should be able to be getting from all of this information this to work out with this formula. So let's see sample 30. So we know it's sample 30. Sum of xy, minus sum of x, sum of y. So in here, again, there is no other way to do this because we don't have a data. So if I had Excel or not, I will not be able to do this because you physically don't have a data set. If I had the data set, by all means, then we put it in, or even in your calculator, and work it out. But if you don't have a data, you need to use this formula. There is just no other way that we could actually do it without the formula. So again, they must give you all the information in this for this formula. So they can't now not give you all the information. So again, if you guys get a question like this, and they don't give you all the information, also let me know so that I can flag it with the lecturer. So let's see sum of x with 465 square. So two things here that you just must be careful about. Here's x square, so it's the x square. Here it is first the sum of x and then to the power of 2. So first sum of x, then to the power of 2, and not directly the x square. So, and again, that will, if you change it, it will create a different answer for you. Okay, so let's now work this out. So 30 times 11502. Yeah, is this correct? Why am I? Let me just make 100% sure and check if 3, 4, 5. Okay. 285045, and then below 30 times 9455. Yeah, sitting with big numbers here. And just in these numbers, very easy to make silly mistakes. Where I already nearly made it with just not adding one of the zeros. So that was it. So again, if this was in the exam, there is really no shortcut for you guys. Which again is unfortunate. Again, it's not difficult, but it takes time. And that again for me is so when we can save time on other questions, because there will be a few that takes you longer than normal. Okay, so 60015 divided by 67425 will give us 0.8901, and then round it off, it gives us that. With this one, I look at this and I would not be able to say, okay, can't be this size or that size. There's no indication nearly of what the slope will be. They didn't give us a formula. So if they've given us a formula, it might have assisted. They just give us those things. So really no indication in any of that what the answers might be. So unfortunately, one needs to work it out the full way. What you might be able to do in Excel is pre-populate a formula like this. So that you might be able to do, or pre-populate this formula, because it's very similar. So that you might be able to do, and then only fill in the numbers, which might save you time. But again, there's really no other easy way to do this. And actually, when you do it, it's not a difficult question. It just takes time. And then very easy, because I made a mistake here, so where I didn't include the zero, so it might be I at least picked it up when I saw I'm now suddenly subtracting something bigger. So that again can also just be clues when you guys are doing this, is just make sure you can even have negative numbers. So it's not that, but make sure that when you look at the things, that it's suddenly not that much bigger than the other numbers. But your slope can be negative, so it's not that if that was suddenly minus 36,5045, that it's wrong. because a slope can also be negative. So just be careful, because where you can see a slope can be negative as well. So yeah, so again, if here was a 0.89 negative, so if there was a negative 0.89, then I would probably have said it's one of those two. So those are again things that you can look out for. So if here was a negative 0.89, so let's say that one was not in there. Let's say that one was not in there, and there was an extra 0.61 negative. I would have been, okay, probably not that answer when it's all between the two ones that have negatives. So again, just things to more look out for than that can be. Yeah, it's one of those that unfortunately with this one, there was no extra information that we could have used to make it simpler. Okay, another question. So again, a question, we don't have data. So there's no information in here that you now could have, again, put in Excel or put in your calculator to work out. So a question like this is very much linked to different of definition types of things that we will have in here, but the definition linked to a value. Okay, so let's again, we don't know beforehand what might be right and wrong, so let's just go from the top. When there is no foot traffic in the store, foot traffic is 0 and store only sells online, sales are estimated to be 6640. Okay, so now important, sales are in R1,000. So when no foot traffic, when that is 0, we see that we will sell so many, 6.64, but because that is in thousands, multiply that by 1,000. So the answer is 6640. So unfortunately, that is correct. So again, we couldn't really do it at any other way than actually going through this question by question. So you need to first know that how we use this. They tell us foot traffic is X. So again, they need to tell it to you. They can't just give you a formula, because I could have assumed foot traffic is Y. So they need to tell you what is X, what is Y, so that you can work it out. Then with the second one, they say 78.1% of the variation in sales is explained by the variation in foot traffic. Okay, so what is your, if we look at this definition, variation in sales is explained by variation in foot traffic. Is it referring to R or R square? So what would you guys have said?
I would have mentioned the R squared.
Okay, perfect. Um, so just make very sure again, when you look at your definitions of coefficient of correlation and coefficient of variation, this is for R square. If we look at that, they give us R square. So this one is incorrect. If we calculated it, the R, we will get the 0.7810. Okay, so if we have calculated R, we will get 0.7810, and then if we put that in a percentage, we will get 78. Okay, so then again, if you didn't know what this definition is, very easily you could have said, oh, but it is R, it is correct. Okay, and again, if you'd done that, you would not even look at the other options because you have already identified according to you what's right. So just be careful, and just specifically for study unit 11, just look at again the definitions of R and R square. And again, it is also in this PowerPoint. I know I included it all in here. So just again, I will bombard you with all the summary slides again later today, that you again have from study unit 1 till 11, my summary pages that I've created. I'll just bombard you. So sorry for the guys that have it already. But I will bombard you with all of that on the WhatsApp group. If you're not on the WhatsApp group, my cell number that you can just send the WhatsApp to me today, 0837908387, and I will add you to the group and bombard you. Okay, so let's just then look at option C and D. There's a positive linear relationship between sales and foot traffic. Okay. The way that we identify positive or negative relationship is by looking at what is in front of the slope. Okay, so if that's positive, there's a positive relationship, and then our R would also be positive. They haven't given us the R, so when we work out the R square and we work out R, remember it can be positive or negative. Because a negative times a negative gives you a positive. So then the link, how we look at it to see if it's positive or negative, is to look at that sign before the slope. So if the slope is positive, your relationship is positive. If a slope is negative, your relationship is negative. So that is also important one nearly to remember. So here, positive linear relationship because the slope is positive. If they have given us R, the R would have been positive as well. So that would have been another way to see if it is a positive or negative relationship. But they haven't given us R, so we need to look at other ways of identifying what the relationship is. Then the last one is the coefficient of correlation, which is R, and we've seen when we work it out, it's supposed to be the 0.7810, which is correct. The other thing that I now wanted to say, so again, here could have been where they say it's a strong positive relationship. Again, so if you look at 78, that is a strong positive relationship. If you add less than 50 nearly, then it becomes weaker. So again, when we look, and again, it is in the slides as well, just look out for things that they might include. So they might say there's a strong positive linear relationship, there's a weak positive linear, there's a strong negative. So even if this was negative, because it's bigger than 0.5, it's still strong. It just might be negative. So don't get confused between negative and positive if it is weak or not. Negative and positive basically indicates, and let me quickly, so that one is a positive slope, so that will have a positive relationship. If your things are scattered like this, then probably that will have a relationship of 0.29. So yes, it's positive, but it's weak. If you have, again, a positive line and your values is lying something like that, then it will probably be something like a 0.8 or even more. Then you can say, again, yes, it's positive, but it's strong as well, because it's nearly lying on the line. Okay. Okay, so that was quickly on few of
Sorry,
yes.
on your previous slide, can you please explain how you work out the R again, please?
Okay, cool. So
Thank
the
you.
R, and again, you will get the R square. So the R square was given. So the R square was given as 0.6099. So basically, to get from a R square to R, we just square root. Okay, so we will square root the R square. So we need to square root the 0.6099. So when we square root that, we will get the answer of 0.7810. So if you square root the R square, you will get the R. Okay, so let me quickly, so if I go to 0.6099 and I square root that, I will get 0.7810. Okay, so just square root the R to the power of 2.
Sorry, can you cover B? Like what would the actual variation in sales be?
Oh, okay, so let's quickly just, so the actual variation in sales would be the 60.99, because that is R square. And they've given you R square as
Okay, thank you.
as 60.99. Okay, so what they wanted to test here is if you know the difference between R square and R. Because if you squared root it, you would have gotten this 78.1. So they wanted to understand, the test here was to test if you know the difference between R square and R. That is basically what they wanted to get out of this question. And how they ask it is if you know what the definition of R square is. So that's what they wanted to get out of here. So How they can differ this question is by giving you R as 0.7810, and they could have asked you exactly the same questions. So again, that might be for the 1610, where you guys have 3 or 4 different questions nearly, or options or different exam papers. They're not going to change the questions that radical. So they could have given you exactly the same, where they just now created and told you R is the value and not R squared. What they also normally would do is might just change some of the numbers. So they could have, instead of a positive, add a negative. And that is just, again, all ways of trying to eliminate that you guys chat to one another. Because let's be honest, you're not going to say, if this was question 24 and you wanted to chat to somebody, you're not going to say, question 24, this is, you're going to say, question 24, my answer was A. And all that will happen is these options will be shuffled with the question. So it's very difficult and really nearly actually impossible to really cheat by telling somebody else on a WhatsApp, my answers is A, B, C, D, and E, because the likelihood that you will have exactly the same question for exactly the same number is very, very difficult. So that is why it's after you've written and you worried that a question was very difficult or strange, or again, afterwards, let me know, because it might have been that by changing some numbers and changing things, that the question was actually not doable. We have seen it once or twice in your assignments. You would have seen it that sometimes it doesn't matter what you try, you're not getting to answer. And it might have been that, again, we sit in a situation where the question was changed from a question in study unit 7 from unknown to known, where you would have used a T and now you need to use a Z, and it might have been that the answer set wasn't. So those things does creep in. So if you feel that there was a question, jot it down. Don't worry about it at that moment. Afterwards, you tell me, and I, like you've seen, I've with specifically with 1610, I really have a close relation with the lecturer, so there's no ways, or there is a way that I can just then say, just look at it. There was a few students that felt they couldn't do it, there's something wrong, and he will look into it. Okay, so that was a few questions on study unit 10 and 11, but I thought also let's just, because there was a few questions on the group around some of the other things in study unit 8 and 9. So I've just added a few more, 3 more that we can do today. And then tomorrow and Tuesday we will start from study unit 1 and work through an exam paper with you guys. So let's look at this one, and let's just, first, you guys can tell me what would you have done. So quickly read through it and tell me with the things that you pick up, what would we have done in this situation?
Try and figure out what type of question it is.
Sorry, repeat that again.
Try and figure out what type of question it is. So yeah, they ask for the population proportion. So then you know if it's a Z test or a T test, right?
Okay, so yes, but already proportion. So, and we've only done Z for proportion. So just be careful. Luckily, they say population proportion. So when we see population, we already nearly see Z, but proportion can only be Z. So just be careful, and they won't do it, but that you don't see sample and proportion together and then think, oh flip, now I need to go to do a T. The only time when you do T is when your sample mean with your sample standard deviation is unknown. So when your sample standard deviation is unknown, we do T. So just be careful with a proportion, that if I use sample proportion, again, touch wood, I don't think they will, but always with proportion we use Z. So perfect. So first we've done Z, 99% confidence interval. What, again, from my table that's in that study guide, what is 99? It's going to be 2,58 or something like that. Again, you please don't nearly study that. It is, I just want to see where it is. So in the study guide, so 99%, 2,58. Okay, so that we already know that your Z is 2,58. If it was 95%, it is 1,96. And if it was 90%, it's 1,645. Okay, I always remember those two. The 99 we don't get too much in the exams, but at least it is also part of one of the tables that, again, you don't need to study it. It is there. You will not get a 98% confidence interval or a 94%, and that is 1510 and 1610. You will not get, so the ones that will be in the questions is always 90, 95 or 99. You will not get anything else because that is not, you don't need to know that. Okay, so they will not ask you to now suddenly work out a 69% or 96% or a 75% or anything like that. It will not happen. It's only 90, 95 and 99 that you need to know. Okay, so then we know we need to work with proportions. So yes, Patrick.
How do we know that out of that test statistic that this is the two-tailed versus a one-tailed? In other words,
Okay.
it's 2.58 instead of 2.33.
Because we're working with a confidence interval. So for confidence intervals, always two-tail. It's when you start with hypothesis testing that with hypothesis testing, the sign in the hypothesis will direct you if it's one or two-tail. So again, you guys can always, when we do our confidence interval, it's always two-tail. So you can, because even if what confidence interval does is really working out, and I just now put the mean, but in actual fact, that mean later becomes a Z, but it basically looks at the 95% around that mean. So that's what confidence interval does. So it always have a lower end and a higher end. It might be in the question, and I think we've done one like that previously, where they say to you, only work out the upper confidence level. Still, it has two confidence levels. It's two tail. So always confidence interval, two tail. The only time when you need to worry if it is one tail or two tail is when you get to hypothesis testing. So please, when it is confidence intervals, always still two tail, because we want to understand the confidence around the mean. So it nearly takes you back to study unit 3 when we did mean, median, mode, standard deviation. So actual fact, what we're doing is with confidence interval, we get the mean and we work out the variance around it or standard deviation around it. So that's in actual fact what confidence intervals does. It looks at the mean and it looks at what our data is spread around that mean. So that's why it's always, there's a spread to the right of it and there's a spread to the left of it. So there's always a spread to both sides. So that's why with confidence intervals, always there's two tails. Okay, hope that also does explain it a bit better for you guys. So confidence interval, always two tail, please. Okay, so now we need to nearly remember, so we will get the proportion, which is 80 over 200, plus minus, and then the Z. And now I'm not 100% sure about this formula. I think it's this. I hope so. So again, not going to work it out now, but that is then just what you will do. So we know what that Z is. We know what the N is. It's 200. We know this is 0. What would that have been? 80. So it would have been 0.4, because it would have been 80 divided by 200 is 40 divided by 100. So it's 0.4, 0.6. So let me, and so we're not going to work it out, but so we know that one in the middle is 0.4. So when that is in the middle, what will happen on that side? It must be a number smaller than 0.4. And on this side, my upper one will be a number bigger than 0.4. So let's look at, so yes, smaller 0.4, bigger than 0.4. So it can be an option. 0.75 is not smaller. So B is definitely not the option. So what they've done here is, if you said 80 divided by 100, you would have gotten 0.8, and then that would have been part of 0.34. Yes, it's smaller. So that can be 0.73. Nope, not the option. 0.31. Yes. So again, if you don't have time, by only looking at what that P would have been, you could have eliminated two options already. So again, if I was with 1 or 2 minutes left, I could then say, okay, well, there's at least only 2 or 3 that I need to guess out of. I would always guess C. I would have been wrong in this instance because E is your correct one. So you guys, I think I have shared it, but I will share it again so that you can just test your answer. So confidence interval with proportion. Okay, then here is one that now is a bit different. So if you look at it, I'm like, sure, what part of the study units was this? Then I pick up, okay, yeah, they talk null hypothesis, so we know it's hypothesis testing, but originally very difficult from just looking at it, what this is about. So let's quickly read through. Governments want to produce low-end smartphones. COVID, okay, this was one of those years that every question was around COVID. Government official wants your assistance in testing the hypothesis that the average cost of a low-end smartphone is more than 100, more than 1,000. So null hypothesis is equal to 1,000. Alternative, more than 1,000. So by looking at more than, is it one-sided or two-sided test?
Upper tail only.
Cool. Upper tail, one-sided. So yeah, one-sided test is actually correct. We are unfortunately looking for incorrect. So because of this being directional, so it's showing us to the upper side, one tail. We don't really need to know if which side. We will later on when we draw the graphs and things, we'll see it's the top end, so the upper side. So very important in the words more than. So more than, smaller than, all of those things show you the nearly direction. The only time when it is two-tail is when it's not equal to. So, and then they would have said that the government official thinks that it is not 1,000 rand. Okay, so when they don't tell you if it's smaller or bigger, they just tell you it's not 1,000. So that would have been the way to nearly make it a two-tail. So one-sided test, cool, that's sorted. Let's look at, because we've jotted down the null hypothesis. The null hypothesis is that the average cost of a low-end cell phone is equal to 1,000. Perfect. So if there was an option of alternative, we would have just said alternative was bigger than 1,000. Okay, so again, they could have asked you had the option of a null hypothesis, or they could have had the option of alternative hypothesis. Critical value 1,96. So let's look at what they tell us. Alpha 0,05. So alpha 0,05. Are we working with a one tail or two tail? Okay, so
One tail.
perfect.
So upper.
Working with upper, one tail. So now suddenly It's not 1,96 because that would have been two-tail. It's 1,645. Okay, so that's the one that is incorrect. Okay, and again, we would have said with that 95%, then very easy to make a mistake to say, oh, but John said, look at the table, 95, 1,96. But remember, we're working with a one tail. So yes, look at the table, but remember, with hypothesis testing, it's different if it was, again, confidence interval, when it's always 1,96. Hypothesis testing, just make sure if it's one or two tail. So again, this was actually a very easy one to get the answer to and get it right, but also very easy to make a mistake. Because they're not going to give you a weird number. They're going to give you the two tail versus the one tail. So if, sorry, if that was 0,1, they're going to look at the 90% and give you those two options. Again, they're not going to give you weird numbers that you know it's incorrect. They're going to give you the two tail versus the one tail. So that you nearly think, but can it be this simple? And I think that is where sometimes it becomes very difficult, is because we, again, look at the subject and it's like, no, but it can't be, it just can't be this simple. They're trying to catch me out. Because, yes, there are questions that they are trying to catch you out, but there are also very, very easy questions. And I think that is what Lynn, that wrote it last year on the WhatsApp group, also said. So the first paper is normally, so again, for the 1510 guys, also that's your study units 1 to 5. Those questions are normally easy, but because it's easy, sometimes one might want to make it too difficult, and you're looking at it and making it too complex for yourself, because we are always in it, but they're trying to catch me out. So when you do the first session on Thursday, just be on the lookout, especially in that study unit 1 to 5. That is where you can easily get your marks. And just be very careful that it might sometimes just look so easy that you're like, no, it can't be this answer. So just be careful with that on Thursday. So let's look at the last one. So this I also thought was an interesting one, because they're giving us very little information. So they tell us it's a two-sided hypothesis test with known population standard deviation. And then they tell us what the p-value is. Okay, so let's look at some of these options. So I would first look at Z. Is Z appropriate or not? So what would you say? Are we going to use Z or not?
Yes,
I would
that
say
is
yes.
Yes,
appropriate.
that.
Perfect. Yes. We know what the population standard deviation is, so we're going to use that. Okay, so unfortunately incorrect one, but again, some of your options, again, might be that you need to say which one is correct. Some of the other guys need to say which one is incorrect. So I will always go to the one that is the easiest to see. So they specifically tell you known population so that we know that it is a Z test that we're working with. Now, the other two options is null hypothesis is rejected at a 5% level. The null hypothesis is not rejected at a 1% level. So let's look at that. So if I've got here the 5% level, then my p-value is here at a 3%. So let's draw that as a graph. So, and I just also want to get to the table so that we can get the last one. So I just want to quickly get to the Z table that I can show you that as well. Okay, so let's quickly. So if the p-value is 0.03, what is this area and what is that area?
Reject.
You multiply it by 2, so it's 0.06.
Okay, what would the other guys have said?
I would say 0.015 you divide by 2 because the total must be 0.03.
Okay, so that's perfect. And I think that is the big catch with this one is they tell us the p-value is that. So then the total p-value is 0.03. So this side is 0.015 and this side is 0.015. Okay, so that is definitely the catch in this question. If they told us that my Z is a certain value, we would have gone to the Z table and gotten a p-value for this side, and then we would have multiplied it to get the total p-value. Okay, so that is, Ravesh, where I think you went, why you wanted to multiply, but they actually give us already what the total p-value is. So definitely this is where I wanted to catch you out. Because if you then look at that value, if you set 0.03 on this side, 0.03 on that side, you would have said, yes, the test statistic is right, because let's quickly look at that. So if you said, because we were looking for that area, which would have been now 0.03. So we're looking at 0.97. We would have had that 1.889 or 885. But we're actually looking for 0.015. So we would have 0.015. What is that in 1 minus 0.015? So we're looking for 0.985. A 985 there. So our actual value would have been 2.17. So 2.17 would have been actually the stat associated with it, because we would have been looking at 0.015. Okay, so definitely that is where they wanted to catch you out. Probably if what they would have done here, because there's only 4 options, I would have added also the associated t statistic is 2.17. Because that then nearly tells me if you would know the difference if I needed to divide by 2 or multiply by 2. Okay, and then just to look at this is at 5%, this is smaller than 5%, so it will be rejected. At 1%, this is bigger than 1%, so it will be rejected. Okay, so again, if you had the 3%, you would have made exactly the same assumption, because you would have said 3%, 3% is smaller than the 5%, reject. 3% is bigger than the 1%, not reject. So you would have made exactly the same assumptions if that is 1.5% or 3%, because of those numbers that would have been. So the only difference would have been if you read it with the t-stat as the p-value or that area as 0.03 versus the 0.015. Okay, cool. So that is the last one for today. So yeah, tomorrow 5:30, and I will send you the links as well again during the day tomorrow, but we'll definitely then just work through an exam example for you guys for Thursday. So Monday, Tuesday, we'll work through stuff, but anything that you need to make sure about, you can do on Wednesday, and then we'll hopefully have a good exam on Thursday. Okay. Have a good afternoon, everyone, and good luck, and we will again chat tomorrow. I will again now share the recordings and everything for you